So, hello everyone. Hello. Am I audible? Sound is not there. Is it now correct? Is sound now available? Guys, am I audible now? Okay. So, is the board visible correctly? Is the letters visible? Very good morning. Very good morning, Uday. Very good morning, Robin Hood. Oh, there is no time to have high voice. Very good morning, Sayed. Yes, Robin Hood, thank you, you are visible. So, let's see. Yes, good morning to everyone. Please wake up, we will start. Please wake up, guys. So, we will start our class today regarding acid-base neutralization, right? I know you have revised your ionic equilibrium very well. Right. I know all of you have revised your ionic equilibrium very well. So today we will start acid-base neutralization. So who is Malleswar Sadhu? He is saying I have not revised. Kartikeya, yes, very good morning everyone. So we have revised, right? We have revised our ionic equilibrium. So let's start from a basic thing. Yes, hi. Let's start from a basic thing. So, do you know what is an SA? What do we denote SA? Strong acid, right? Is it coming as a mirror image? Is the live coming as a mirror image? Is it coming correct? So, strong acid. So, let's see. Strong acid, अपने पास strong base है. Again, weak acid we have, and we also have weak base, right? Is it correct or wrong? So what will happen? When we react strong acid with strong base? अरे comment में जवाब दो. Please answer in the comments. What will happen when we react strong acid with strong base? Then we can also react weak acid with weak base. Then similarly we can react strong acid with a weak base, and then we can also react weak acid with a strong base. So we are having 4 combinations, right? 4 different combinations for an acid-base reaction. So one second guys. I think I need better visibility of this. So now I think this is more better. So we'll have 4 combinations, right? So 65 students are live. At least 100. Less than 100 will not entertain you. Less than 100 will not entertain you. So first case, strong acid plus strong base. What will happen? Acid plus base. What will happen? Acid plus base, neutralization. Strong electrolyte. Acid plus base, neutralization. Salt plus water, right? Salt plus water. If strong base and strong acid will react with each other, so can I put the reversible sign? No, I cannot put the reversible sign. I have to go forward and it will neutralize completely, giving me a neutral salt, right? Neutral salt. Board is not clear. What is your clarity, beta? Manoj, can you increase your clarity to 480p? Can you increase your clarity, YouTube video clarity to 480p? Okay. Is it clear now? So only 73 of you are joining. Please reach it to 100. Share kar do. Share with all of your friends. So again, strong acid can react with a weak base. So what will happen? What will be the nature of that salt? In the third case, what will happen? A weak acid can react with a strong base, right? What will be the nature of that salt? Acidic salt. Very good, Rajkumar. So here this one will be acidic salt. and a weak acid plus strong base, that salt will be basic in nature. And in the fourth case, what is that? Weak acid, weak base case. We all know that it depends on the relative strength of the respective acid or base, right? So agar we are taking weak acid or weak base, then it will depend that whichever is stronger. Like if weak acid is stronger, the strong salt will be acidic salt. If the weak base is stronger, the salt will be basic salt. So at the end of the day, we are getting three types of salts, which is neutral salt, acidic salt, and basic salt. So before going to salt analysis is a very important chapter for NEET aspirants as well as mains and advanced. Every year we will get one question from salt. Okay. Red pen is a problem as always. So we will avoid red pen today, only blue and black. So we know that salt analysis gives us very good score in the mains and advanced. So can you pause the video? Can you pause the video if you are taking a note? Then we'll discuss about the types of salts, right? So can I clear this part? So neutralization reactions we all know from our 10th and 11th. Now, this salt, strong acid. So strong acid we can take HCl, a very good monoprotic strong acid. And we can take a strong bases NaOH, right? Our favorite ones. So what neutral salt we will get? NaCl, correct? Then we can take our strong acid and HCl again, right? Then we can take our weak base as NH4OH. NH4OH, right or wrong? We can take NH4OH or not. Then what will be our acidic salt? NH4Cl. So ammonium chloride will be acidic salt because it is made of a weak base and strong acid. Similarly, what will be our weak acid? CH3COOH, acidic acid. Then acetic acid can react with a strong base. Someone like NaOH, KOH or something. Then what will it give? CH3COONA, right? This will be a basic salt. So let's see. You will get a lot of examples from different types of salt. So now let's divide the salts in different categories and we'll discuss about them. So even now the board is not clear. Who is having that problem till now about board is not clear? Even now the board is not clear, dear. Varsa, still the board is not clear. Can you increase your clarity? Go to the advanced setting option. Do you know how to increase YouTube quality? Can you increase your quality of your YouTube video? SK Asu, can you increase your YouTube video quality? Okay. So can you increase your YouTube video quality? Increase it up to, I think 720 or 480 will work. If your internet is okay. Oh, Sammy Sahed. no time for comedy. So let's go to our main part. Right. We'll categorize salts in different parts. Then we'll discuss about salt hydrolysis. That is our main part, right? Then we'll go to pH curves. So JEE advanced main student, please be alert. We'll go to pH curves then. So first thing, salts. So salts can be of different types. First of all is a simple salt. Okay, we know salt is made up of a cation, which is our positive part, plus a anion, right, which is our negative part. And salts can be of different types. One is first very simple thing, simple salts. Now only we are discussing. It can be made by simple neutralization of an acid as well as a base. Then we will get some compound salts, or we tell them as double salts, where two salts are in a complex. double salts, where two salts are in a complex, but whenever you put them in water, whenever you hydrolyze them, so whenever you hydrolyze them, they will break into respective anions and cations. Then complex salts. So complex salts are something very different, and we have a very vast chapter on this coordination chemistry in your second year. So now we will just understand what are the basics of the complex salts, and in the fourth category we are having a mixed salt also. Mixed salt. So salts, we can divide salts roughly into four categories. First is very simple salts, second is double salts, third is complex salts, fourth is mixed salts, right? Yes or no? Yes or no, beta? So mixed salts, let's start from the difficult one, or let's start from the simple one. Simple salts. So we have neutral salts, right? Salts made up of strong acid and weak base. Sorry, strong acid and strong base. NaCl. Na2SO4, all sulfates. Okay, then so all the alkali and alkaline metal, earth metal sulfates and chlorides. Got it? You know, right? All the alkaline metals, alkaline earth metals and alkali metals, sulfates and chlorides, right? So KCl, can I write MgSO4? Can I write NaNO3? So all of them will be in the neutral salt category, whoever are made from a strong acid plus strong base. We all know this. We all know this from our lower classes, right? Once more, a strong bases we can add, right? Igneous. Yes, you know. Then next part is acidic salt. I think my board is visible. So acidic salt. Acidic salt. We need a dominant strong acid plus a weak base. So dominant strong acid will be our chloride, HCl, or H2SO4. Then we can use weak base as ammonia or NH4OH. Correct? So NH4 ammonium sulfate. This is our acidic salt. Okay, board not clear. Okay, please everyone understand once again. Whoever facing any problem in the board clarity, please go to the advanced section and increase your quality of the YouTube here, quality of the YouTube video up to 720. Okay, up to 720. Then increase your increase your YouTube video quality up to 720. Very simple. It's very clear. Then basic salt. So basic salt also we need a strong base, very strong base and a weak acid, right? Very strong base and a weak acid. So just make it a very strong base and weak acid. So bear with us, today is the first day. So strong acid will be, strong base will be our NaCl. So we can do CH3CONa or CH3COOK, or what we can add? CH3 whole CO whole 2Ca, right? We are taking acetic acid as our weak acid. We can take formic acid, we can take carbonic acid, right? We can take a lot of weak acids and we can play with the salts. And you know the crisscross, right? In every class we have discussed crisscross like more than 5 times, so you know all of them, right? Then let's go to our most important category of today's class, double salt. How double salts are formed and what are the most important examples in the double salt category. So double salts can be formed by a complex or a simple addition product of two different salts. So first of all, let's discuss about ferrous ammonium sulfate, which is more salt. Okay, more salt. FeSO4 dot NH4 whole 2SO4. Okay, ferrous ammonium sulfate, like iron sulfate and ammonium sulfate added together with 6 water molecules. So this is a very important salt and the name is Morse. M-O-H-R, Morse salt. Right? Then another one is potassium. Potassium can be named as potassium sulfate, aluminum sulfate, 24H2O. So can I erase this mixed salt part? We'll discuss it later, mixed and complex. So next one is potassium. K2SO4, then Al2 whole 3, Al2SO4 ka whole 3 dot 24H2O. So do you guys know that fitkiri thing we rub in our face after shave? So this is potassium. I think all of you know about Morse salt and potassium. But can anyone say what is this 6H2O? What is this 24H2O doing here in this salt? Can anyone say? Charan, can you say anyone? What is this 6H2O and 24H2O doing in this salt? So only 74 people attending the class. Please share the link. At least increase into 100. Only 76. So at least increase into 100. My question was, what is this 6H2O and 24H2O doing here? Please explain. So this is called water of hydration. Water of hydration, right? So some salts need or absorb some water of hydration to make the addition compound. Okay, you have to add these two different salts in some water and it will absorb and make another solid as this double salt, which is Morse salt. Remember the name, Morse salt. Ferrous sulfate, ammonium sulfate dot 6H2. Very simple to remember. Then potassium, potassium sulfate, aluminum sulfate, that 24H2O, right? So we need 6 molecules of water and 24 molecules of water to make the double salt. So hopefully this much is clear. I am getting out of the way. You can take a very simple screenshot and then we will move to the next part, which is complex salts and mixed salt. I think while discussing about, we discussed some complex compounds, right? While discussing about that copper complex. Right, so let's see what is the complex salts, then we'll go to the mixed salts, then we'll start our main topics for today, salt hydrolysis. So please take a screenshot. Why only 73 people are here? Please increase the number. Please increase the number. If you have not taken a screenshot, please go back and take the screenshot or pause the video and note it down there. So only 74 people, very less. Please share with your friends. We need at least 100. Right, sir, please volume. Please reduce the volume. Okay. Yesterday festival. So due to festival, some people are not coming. Okay. Okay, volume this much, okay. Is echo still coming? Is echo still coming, guys? Please, some of you, is echo still coming? Is volume okay? Anyone? Anyone can mention in the comments, mention in the live chat box. Is echo still coming? Is volume okay now? Are Vivek Reddy, we have explained everyone. Please increase your quality of the video up to 720p. Then only you can see the board clearly. So complex salts. So please can someone write down in the comment that we have to increase the video quality up to 720 or 480p to get very clear view of our board, right? So complex salt and mixed salt. So sometimes in your board exams they will ask a difference between these two, and you can write down that difference also. I will not write down all the points. You can write down from your reference books, from your IP books. Okay. So complex salts are coordination compounds, right? K4FeCN6. Here a coordination sphere. We discussed this, right? This square bracket means coordination.
Who is calling? Who the hell is calling? Sir, 68 knots. One second. Let me.
Okay, hello 67 W audio. W audio? अरे क्या बोल रहे हो आप लोग?
So,
sorry guys, sorry for the interruption. Sorry guys. Keep in Zoom. All will come. What happened, sir? Sorry for the interruptions. Sorry for the interruptions. So someone have written potassium ferrocyanide. Very good. Tetraammonium cupric sulfate. Very good, Charan. Okay. Nothing happened. Let's get back to the normal. So we understood what is a complex salt. Okay. We understood what is a complex salt. It's a coordinate compound, and we will learn in your second year. We'll learn a whole chapter, and which holds a very big weightage in your JEE Mains and Advanced and your NEET exam as well. So we want to see our friends start Zoom classes. Arey beta, Zoom cannot handle this much. In YouTube also it's difficult to handle you all. Zoom cannot handle this much, and we have a lot of limitations in Zoom. So that's why we chose YouTube. And don't think that we have not tried Zoom and we are coming to the YouTube straight. So we have tried Zoom, we have tried JEE Meet. Now only we have coming to. Okay, so let's see what is the mixed salt. Mixed salt which can furnish or which can give. Furnish means which can produce, right? Which can furnish more than one cation or anion. Okay, which can furnish more than one cation or anion. So let's discuss some examples. CaOCl2. Can anyone tell me the name of this salt? CaOCl2. CaOCl2. Can anyone tell me the name of this salt? All of you know from your school level. Array, can anyone tell me the name of this salt? And what are the anions and cations it is producing? CaOCl2. Calcium hypochlorite. Okay. Array, please tell me the common name. Don't copy from Google. Can you tell me the common name you have studied in your 10th class? Do you remember something like bleaching powder? So it will produce one cation, calcium 2 plus, and two anions, OCl minus and Cl minus. So two different anions and one cation. This is very famous bleaching powder. How can you forget? Then here, this is the example where we'll get two cations and one anion. So what will be the two cations, beta? What will be the two cations? Na plus and K plus, right? The anion will be SO4 2 minus. So Na plus and K plus will be two cations, and the anion will be SO4 2 minus. So hopefully we are very clear about the difference between complex salts, which are the coordination compounds, and mixed salts. So mixed salts are the species which can furnish more than two anions. First is our very famous bleaching powder, and the second one is very infamous. So NaKSO4, sodium potassium sulfate. That is also very famous salt. So only 60 members, 70 members joined. So this is a very disappointing day. But as our first class, I am also happy with that. So this is our basic about salts. Now we will go to the advanced part. So be careful, fasten your seat belt and sit with your copy. Don't roam outside and check the YouTube video. So salt hydrolysis. This is the most important part in the ionic equilibrium chapter for all the JEE advanced and JEE main students. Okay. Salt hydrolysis as well as all NEET students. So if some NEET people are here, don't think that this class is useless for you. Salt hydrolysis. Okay. It's going out of our view. Sorry guys, sorry. Salt hydrolysis. तो आप लोग कनेक्ट हो जाइए, अपन कल जब लाइव वीडियो स्टार्ट करेंगे आप सबको यू विल गेट द नोटिफिकेशन देयर. ओके, प्लीज बी कनेक्टेड. सो सॉल्ट हाइड्रोलिसिस विल स्टार्ट. फर्स्ट ऑफ ऑल, कैन यू एक्सप्लेन व्हाट इज हाइड्रोलिसिस? कैन यू एक्सप्लेन व्हाट इज हाइड्रोलिसिस? व्हाट इज हाइड्रोलिसिस? Reaction with water, right? What will happen if you put something in water? That is hydrolysis. So only 70 people. Please increase. Please increase and tell to your friends at least 100. I know every one of you have the smartphones. So at least 100 we are expecting here. Okay. So reaction with water. What will happen if you put something in water? So first of all, we know water will dissociate as H plus and OH minus, right? What will dissociate as H plus and OH minus ions. And what will happen if you add someone like NaCl in water? NaCl in water, what will happen? NaCl will also dissociate. And all salts are strong electrolyte. So alpha is equal to nearly is equal to 1. So what will happen? It will dissociate as Na plus and Cl minus. No reversible arrow, but water will dissociate with a reversible arrow. It will give us H plus and OH minus, right? So be careful, listen carefully. We are going to a very difficult topic. So first we will discuss what will happen in hydrolysis of salt of weak base and strong acid. So in starting of this session, we have discussed about this cross, right? What was happening? What are the possibilities? This strong acid can react with strong base. This strong acid can react with a weak base also. Can weak acid react? No, right? It will react with a base only. So this strong acid has two possibilities. It can react with a strong base as well as a weak base, right? What Uday is saying? Okay, what someone is saying? Okay. And then this weak acid also has two possibilities. It can react with strong base as well as the weak base, right? Okay, reflection. Oh, what to do? A lot of problems coming together at the same time. So I will write below the reflection. I am getting your point. Okay. The reflection is coming just on the strong acid. So we'll write on this. We'll move the camera a little bit. 780p, 720p also no clarity. Can you check now? If 720p is not giving any clarity? So let's see what will happen when we react a salt, when we make a salt of. Okay, lights are already turned off. Clarity. So what will happen is salt of strong acid. First combination is salt of strong acid. A salt of strong acid plus a weak base. So do you know any strong acids? Yes sir, we know. Do you know any weak bases? Do you know any weak bases? Do you know any weak bases? NH4OH, right? Ammonium hydroxide. So what will be the salt? First of all, can you decide what will be the salt? NH4OH, and this will react to give us NH4Cl. Then let's hydrolyze. Hydrolysis means just put that salt in water. Just put that salt in water. Okay. So just put that salt in water. NH4Cl will be added to water. Then what will be our final products? What will we get? So what will happen again? This NH4Cl will again react with OH minus of water and give us NH4OH plus HCl, right? So always focus on the weak part. Always focus on the weak part and strong part. Why I am saying this as weak part? Because this is a weak base. And why I am saying that as a strong part? Because that is a strong acid. So always focus on this weak part. So how this weak part is made? NH4Cl is reacting with water to give us NH4OH, right? NH4Cl is reacting with water to give us NH4OH plus a proton from water. So can I remove this Cl from this side? NH plus NH4 plus is reacting with water or is hydrolyzed by water to give us NH4OH, which is the weak part. We have to focus on weak part. We'll know why we're focusing on weak part after a short while. So please be patient. Is it a cation or anion? So this is a cation, so we call this as a cationic hydrolysis. Class ippudu nunchi are beta telugu raadu. So cationic hydrolysis. अपन को तेलुगु नहीं पता, आप तेलुगु में कुछ नहीं बोल सकते इधर. तेलुगु में कुछ मत बोलिए, आप हिंदी में बोलिए, अंग्रेजी में बोलिए, कुछ भी बोलना है कमेंट्स में, we'll discuss. So this is a cationic hydrolysis of a salt of strong acid and weak base. Hopefully up to this is clear. So this will be our equation 1. And all of you know, whenever we get a new equation, the chemist inside us, the chemical equilibrium, ionic equilibrium specialist inside us tell us to write the equilibrium constant. So can you write equilibrium constant? Can you write equilibrium constant for the equilibrium 1? Can you write the equilibrium constant? What will be the equilibrium constant here? So K will be product by reactant, right? Again, what will be the product? NH4OH into H plus the concentration divided by what are the reactants? NH4 plus multiplied into concentration of water. Again. Do you know this water is in excess, right? Previously also while doing the mixture, while calculating the pH of the mixture of weak acid, weak base, strong acid, strong base, we have to ignore water, right? We can ignore the concentration of water, or what we can do? We can simply multiply the concentration of water, because the change in concentration of water will be very less. When a weak electrolyte is reacting with water, it can use very less amount of water, because water is also weak electrolyte and this is also weak electrolyte. So we will have very less change in water, and this water will be constant, and it can be multiplied to this constant, and again constant into constant, we can write a new constant KH, which is hydrolysis constant. Hydrolysis constant. KH will be hydrolysis constant, which can be denoted as product of hydrolysis divided by reactants of hydrolysis, right? Is it correct? NH4 plus. So KH will be NH4OH plus multiplied into H plus divided by NH4 plus. So did you understand? The hydrolysis constant is something new which is coming as KH, and we can keep it as equation 2. So for first equilibrium, we are getting equation 2 as K hydrolysis, which is, okay Asu, okay, we'll repeat. So what is happening? This NH4 plus is hydrolyzed by water, and what will happen? Water is giving us OH minus and H plus. So this OH minus can react here, right? This OH minus can react with this, and then we'll get NH4OH plus water. We'll get NH4OH plus water. Got it? Are you clear about this reaction? Then what can we write the equilibrium constant? Equilibrium constant will be always concentrations of product divided by concentration of reactant. What are our product? NH4OH and H plus, right? What are our reactants? NH4 plus and water. So again, amount of water is always like very less consumed. So amount of water is more or less same. Like you have 10 liters of water and you are dissociating only 20 or 50 ml of water. So the amount of water will be almost same. So can I ignore? Can I take this constant into this side and make this as KH? KH is called as hydrolysis constant. Capital K subscript H. So we are getting it as hydrolysis constant, which can be defined as multiplication of the reactant products divided by reactant for this hydrolysis. And this is a cationic hydrolysis, right? Why cationic hydrolysis? Because we are hydrolyzing this NH4 plus. We are hydrolyzing NH4 plus, and you know that NH4 plus is a cation, right? Very simple, very basic concepts. So we'll keep that. We'll keep the KH. We'll keep the equation. We'll just erase this. We'll just remove this. So even if you don't write, just go back in the video and you can write. If you are taking screenshot, just go back and pause and take a screenshot. If you are not doing anything, just enjoy the class. Okay. So we got the KH. Now, what is happening in the system? What is happening in the system, beta? We are having this salt also, right? We are having this salt is hydrolyzed. We are having this weak base. We are having this weak base in the system again. We are having this weak base in the system again. We are having this weak base in the system NH4OH, and the weak base will dissociate as NH4 plus OH minus, right? Can I write this as equation 3? And do you know what will be the equilibrium constant here? What will be the equilibrium constant here? Base constant Kb, right? We know for a weak base, the base constant Kb will be a product by reactant, right? Similarly, what else is happening in the system? So can I write here? Yes, water. H2O can also take, right? 2H plus and OH minus, because water is also in excess in the system, so it can also break and it can give us H plus and OH minus. What is water constant? Kw. Equation, make it equation 5. So can you write Kw? Kw will be H plus OH minus divided by what are the concentration, and we know water is in excess, so we can remove Kw will be H plus into OH minus. And again, what will we write for Kb? What will we write for Kb? NH4 plus OH minus into NH4OH divided by NH4OH. So make this as equation 4, this Kb value as equation 4 and this as equation 6. So we are having three different values. We are having three different values in one system. We are having three different equilibriums. So we are having three different equilibriums in one system. First one is salt hydrolysis. First equilibrium is the salt hydrolysis one. First equilibrium is the salt hydrolysis one, where we have calculated the kH, which we have given the equation 2. Then the second equilibrium is the dissociation of the weak base, where we have calculated this Kb, and we all know what is Kb, right? Then the third equilibrium in the system is water itself. And we know what is Kw. We know what is Kw at 25 degrees centigrade, right? We know what is Kw at 25 degrees centigrade. Can anybody comment it down? What is the value of Kw at 25 degrees centigrade? Can anybody comment it down? What is the value of Kw at 25 degrees centigrade? Are you are learning ionic equilibrium for more than 2 weeks? You should be able to answer this. 14, right? How all of you are forgetting this? 1.89. अरे pKw का वैल्यू कितना है? 10 to the power minus 14. Then pKw will come as 14, right? 10 to the power minus 14 and it will come as 14, correct? So all these three equations in our mind. So can you take a screenshot? Then we'll do our best part. We'll relate. We'll have a relation between KH, KW and KB. So can you write down up to this much? Then we'll relate. Take a screenshot, guys. Okay. Pause and take a screenshot. Go back, pause and take a screenshot. So I will erase everything. I will keep the KW, KH and KB together and you will tell me a relation. Or we will derive a relation together. Okay. So we know KB, what is KB? We know KH, we know what is KW. KW will be H plus ion into OH minus ion, right? Correct. Then, so let's try to derive something. First, let's write down all the equations. Correct. This was the third equilibrium, which is giving equilibrium constant Kw. Then, what was the second equilibrium? The dissociation of weak base. NH4 plus and OH minus. This was also giving us equilibrium constant as Kb. Then what was the parent reaction? NH4 plus water. NH4 plus water will be in equilibrium with NH4OH plus H plus. So have we done this type of problem in chemical equilibrium? And this third equation, this first equilibrium is having equilibrium constant as KH. So have we done this type of problems in chemical equilibrium? What will happen? How you can get this final equation from the above two equation? Can anybody say what can I do to this equation 3 and equation 2 to make our final equation? What can I do? Can I rotate? Can I reverse this reaction so that I can get this as our product? I need NH4OH as our product, right? Here it is in reactant side. So can I reverse this reaction? Yes, very good. So I will reverse this one and we will get the final answer, right? If I reverse this, what will be cancelled out? This OH minus will be cancelled out. OH minus will be cancelled out, and we will have This NH4 plus as reactant and this water as reactant. Correct? And we'll have this as product and this H plus as product. Correct? Correct or not? Then what will be the value of KH? KH is the final equilibrium constant. What will be the value? Can you write down? KH will be, can you write down in the comment what will be the value of KH? Parent equilibrium constant is the multiplication of both the equilibrium constants. So here we are reversing the Kb, right? It will be 1 by Kb and initially it was Kw. So can I write Kw into 1 by Kb? Can I write KH as Kw into 1 by Kb? Can I write? Can I write KH as Kw by 1 by Kb? Yes, very good.
So please take a screenshot.
Please take a screenshot. This is the relation between Kw, KH and Kb for strong acid and weak base salt hydrolysis. So write down this heading and take a screenshot. What is the relation? So do you understand what is the relation? So write down or take a screenshot, then we will move to the text part. Thank you, thank you. Don't spam as simple. Everyone is requesting, don't spam. Please, let everyone learn. So I salute you all. I salute all my 60 students who are watching from beginning to the last. I salute and I will be always with you. Don't worry. So just go back and pause the video. Take a screenshot. Don't spam in the comments. I salute all the 60 students who are watching from beginning to the end. Like before starting also there was 50 people waiting. So I really appreciate your efforts. You are studying hard and you will be sitting in one of your top engineering college. You will be sitting in one of your dream engineering college, right? So now we'll go to the best part. We'll calculate the pH. Okay? We'll calculate the pH or pOH of the hydrolysis. So NH4 plus is reacting with water, or NH4 plus is hydrolyzed in presence of water. What we are getting? At a previous equation only, NH4OH plus H plus, right? NH4OH plus H plus. So what was the relation there? KH was coming as Kw by Kb. Do you remember this one? Now only we derive it. So let's see. This will be initially at time t is equal to 0. At time t is equal to 0. Let this be 1. This will be, don't consider this because this is in excess. This product will be 0 and 0, right? 0 and 0. Then at time t is equal to T equilibrium or T hydrolysis. Okay, when the hydrolysis is completed, what will happen? 1 minus alpha, or this will be alpha. If the total concentration or initial concentration of salt is C. So what will happen? 1 minus alpha into C alpha, right? We all know this. Then, do you all remember Oswald's law of dilution? Do you not remember Oswald's law of dilution? For a weak electrolyte, Oswald said that the alpha will be equal to, Oswald said that for a weak electrolyte, alpha will be equal to root over of equilibrium constant. What is the equilibrium constant here? Hydrolysis constant, right? Kh by alpha will be equal to Kh by C, right? Kh by C. Okay, so we need the Kh. Can we write this as
Rudradev, while there, you told to the students that 12:15 physics class, special lecture will come.
Zoom?
No, not this.
How?
You should create 12:15.
Okay, guys, the news coming that we are having a physics class on 12:15, and you will be given the link as soon as the chemistry class is completed. So don't worry, please enjoy the chemistry class first, then we will go to the physics class. Okay. So Oswald's law of dilution says that equilibrium constant will be C alpha square. And here we need to calculate pH. So what concentration we need? We need C alpha only, right? We need C alpha. We have the value of alpha. So can I put C into value of alpha will be Kh by C. So this C goes inside, Kh into C square divided by C. Can I cancel this out? So what will be the value of H plus ion concentration? It will be Kh into C, right? H plus ion concentration will be Kh into C. And we know the value of Kh. What is the value of Kh? Kb by, Kw by Kb. So can I replace that? You can take this as 1, write this as 2, then write this as 3. We are getting H plus ion concentration as Kh into C, as we are deriving the weak electrolyte, pH. This is the very similar thing. So can I, so take a screenshot of all of this. Take a very good screenshot and note it down. I will check all of your copies when you arrive here physically. So take a screenshot. Take a screenshot. We are not at all serious today. Just chilling, just having a good class. Okay. Ramesh Chinna, come to the campus. We'll see. So okay. So let's clear this Oswald. So we got the H plus ion concentration, right? H plus ion concentration is Kh into C ka root over. So can I put the value of Kh, which is Kw by Kb? Now only we got before this slide. So H plus ion concentration is equal to root over of Kw by Kb into C. So how to convert it into pH? Minus log H plus, right? Minus log H plus we can write, which will be converting it into pH. And this will be Kw by Kb into C. So can you do this? Can you take this root over as minus and take it out as half? Yes. Can you write this minus log H plus as pH? Can you write this minus log H plus as pH? And can you take this minus half out? Logarithm of Kw into C divided by Kb, right? Logarithm of Kw into C divided by Kb. So I am erasing all of this. Let's do it here only. So we got pH is equal to minus half into log Kw is in denominator, so it will be Kw plus log C. And what is in the denominator? It will be minus, right? Log Kb. Are log A by B, log A plus minus log B, right? Log A by B will be log A minus log B. So we will get this much. pH will be half into log Kw plus log C minus log Kb. So can I multiply this minus half? Minus half of log Kw minus half of log C will be plus half of log Kb. Right? pH. So this is the pH formula at any temperature. At any temperature where Kw value is not known. But at 25 degree centigrade, can you say what is pKw? So pH will be half is coming outside. It will be pKw minus half log C, and this will be minus half pKb, right? pKb is minus log Kb, right? So up to this much clear. Can you take a screenshot of this side? So what will be the value of pKw? What will be the value of pKw? What will be the value of pKw at 25 degrees centigrade? Now only all of you told what will be the value of pKw at 25 degrees centigrade? 14, right? अरे आप लोगों का साबुन स्लो हो गया क्या? Half log C plus half log minus half log pKb. So can I take a minus half common out of here? What will be 14 by 2? 7, right? So 7 minus half pKb plus log C. So pH at 25 degrees. pH at 25 degrees for a hydrolysis of a salt of strong electrolyte, strong acid and weak base at 25 degree. Okay, so we got a pH value for the hydrolysis of salt at 25 degree centigrade of a salt of strong acid and weak base. The pH will be equal to 7, which is half of the pKw. Okay, which is half of the pKw. And this is minus 1 by 2 pKb plus log C. You know what is pKb? Kb value is given 10 to the power minus 5, then pKb will be 5. So now is the video is blinking. Can you take a screenshot now? I am going out. Can you take a screenshot? Can you take a screenshot? Everybody taken this screenshot of this equation? Very important derivation. pH for a mixture of hydrolysis of salt. Okay, right side of the board is not visible. Which part? That at any temperature. Okay, now visible. Now is it visible correctly? At any temperature, now is it visible? So everybody please take a screenshot. Please take a screenshot. Okay, so all of you understand what is the pH of hydrolysis of a salt of strong acid plus weak base, and do you realize how long is the derivation? How long is the derivation? So at least it should have taken you 3-4 screenshots, and when you write this in your copies, it will have you will have a very big derivation. So for your JEE perspective, we have to only remember this, that pH will be pH for a mixture of salt of strong acid and weak base will be 7 minus half of pKb plus log C. What is C? What is C? Initial concentration of salt, right? Initial concentration of salt. C will be initial concentration of salt. Okay. You understand? So we'll have something new when you come back. We'll have chocolate problems once in a week. So let's see who can do all those problems and get some chocolates. Okay. If nobody can do, I will eat in front of you. So please enjoy. Please enjoy your holidays. We'll meet in the next class tomorrow. I think at the very same time. And thank you for all the 70 people who are till now watching, responding to all the questions, and you are very interactive today. I enjoyed taking the class. Srivastava Arya, why are you sad? So I enjoyed taking the class. I hope you also all enjoyed, and take the screenshot of this final thing. If you have not taken it, please write down, update your notes, come back to physical mode very soon. So I hope all of you enjoyed. Enjoy your vacation. We'll enjoy when you meet again. So thank you everyone for joining. Thank you everyone for joining. Okay.